Good day! In this video, I am going to show you a sample problem on how to solve stress and strains axial loading involving temperature change. For the problem, determine the compressive force in the bars shown after a temperature rise of 82 degrees Celsius and the corresponding change in length of the bronze bar. So let's identify the given first. A for the area, which is for the aluminum, is 1,500 square millimeter, and for the bronze, it is 1,800 square millimeter. And E for the elasticity, for the aluminum, it is 105 GPa, and for the bronze, it is 73 GPa, and alpha for the coefficient of thermal expansion, and the and for the aluminum it is 21.6 times 10 to the power of negative 6 degree Celsius, and for the bronze it is 23.2 times 10 to the power of 6 to the power of negative 6 degree Celsius, and for the length of the aluminum it is 350 millimeter, and for the bronze it is 450 millimeter, and delta for the constraint expansion, which is 0.5 millimeter. In letter A, determine the compressive force in the bars shown after temperature rise of 82 degree Celsius. So let R be the compressive force in the bar. The formula for the compressive force is equals to L times alpha times delta T minus R times L over A times E plus L times alpha times delta T minus R times L over A times E is equals to delta. Then you have to input the given. So it will be 450 times 23.2 times 10 to the power of negative 6 times 82 minus R times 450 over 1800 times 73 times 10 to the power of 3 plus 350 times 21.6 times 10 to the power of negative 6 times 82 minus R times 350 over 1500 times 105 times 10 to the power of 3 is equals to 0.5. The answer for this is 1.476 minus 5.646,879 times 10 to the power of negative 6 R is equals to 0.5. And you have to transpose the R values and the 0.5 values so that it will be eliminated. So it will be 1.476 minus 0.5 is equals to 5.6468797 times 10 to the power of negative 6 R, and the answer for that is 0.976 is equals to 5.6468797 times 10 to the power of negative 6 R. In this case, there is still a value in the compressive force, and we have to eliminate it, and it will become R is equals to 0.976 over 5.6468797 times 10 to the power of negative 6. And the final answer is R is equals to 172,838.8157 Newton, which is the compressive force in the bar. B. Determine the corresponding change in the length of the bronze bar. We know that R is equals to 172,838.8157 Newton, as we solved earlier. So the formula for the corresponding change is equals to delta B for the bronze is equals to length times alpha times delta T minus R times L over A times E and input the given. So delta B is equals to 350 times 21.6 times 10 to the power of negative 6 times 82 minus 172,838.8157 times 350 over 1,500 times 105 times 10 to the power of 3. The answer for this is delta B is equals to 0.2356 millimeter. It is for the corresponding change in the length of the bronze bar. Thank you.